So this is about the structure of the vertebra. Structure of the vertebra. If you take structure, here we'll be having first two structures. First one, cylindrical shape of body, cylindrical shape of the body of vertebra. Suppose if you take body, it will be like cylindrical shape. This is the body of the vertebra, and irregular shape of the arch of the vertebra, irregular shape of the posterior portion. This is vertebral arch. This is vertebral arch. This is body of the vertebra. So this is the structure of the vertebra. If we take body of the vertebra, if we take body of the vertebra, body of the vertebra, we are seeing lateral view, body of the vertebra. Inside the vertebra body, it is going to formed by the bone called spongy bone. It is going to formed by the bone called spongy bone, also called as trabecular system. So this is trabecular system. So this spongy bone is covered by the strongest layer. This spongy bone is covered by the strongest layer. The strongest layer name is called cortical bone. This is the cortical bone. Inside we'll be having spongy bone. This is about body. So here one more point. Suppose imagine here we'll be having posterior arch of the body, posterior arch of the vertebra. The stress which will come on the vertebra, the stress or force which will come on the vertebra, it is going to come more on the cortical bone compared to the trabecular, compared to the spongy bone. The stress which is the stress or load which is coming over the vertebral body, it is going to be more on the cortical bone. It is going to be more on the cortical bone and less in the spongy bone. At the same time, the stress which is facing by this anterior portion of the body is more compared to the posterior portion of the body. So in this anterior portion, the stress will be more. So that means this vertebral body can take more stress in anteriorly compared to the posterior arch of the vertebra. If we see the body of the vertebra, here outside it is completely cortical bone. So if we see the body of the vertebra, the cortical bone will be thick and more. It is more thick and more at the rim of the vertebra. This is superior, this is inferior. So at the rims of the superior and inferior rims, the cortical bone thickness will be more, and in the center, it is going to replace by the hyaline cartilage. It is going to replace by the hyaline cartilage to form the cartilaginous end plate. So this cartilaginous end plate will be look like this. So here this is epiphyseal plate, and the portion which is here present here, this is nothing but the cartilaginous end plate. So this is the superior aspect of the cartilaginous end plate. Whereas if we come to trabecular system, otherwise spongy bone. If we take the body of the vertebra, here this trabecular system is vertical. The trabecular system in the body of the vertebra is vertical. These type of vertical trabecular system are going to helpful in the resist of body weight, are going to helpful in the body weight transmission, and at the same time resist the compression force. So for body weight transmission and resist the compression forces, this vertical trabecular in the spongy bone is going to helpful for the body. And second one, the other trabecular system. See here transverse oblique. This other trabecular system are going to helpful for the complete vertebra. Other trabecular system are going to helpful to resist the shear force. What is this shear force means? Suppose if we take one object, if you apply one force in one direction, so that the object has to move. The object will move. So to prevent this shear force system, these other trabecular patterns are going to helpful for the vertebra. So here if you see all trabecular system, the area where the trabecular system is less, this is nothing but the zone of weakness of the vertebral body. So that this weakness area, here there may be higher chance of fractures or injury, because here trabecular system is less. So that way this is the zone of weakness of the vertebra anteriorly. So that way here fractures or injuries will happen very easily at the anterior portion of the vertebra. So this is about the body of the vertebra. Here which fracture most common means compression fracture. Compression fracture means from here one force will come, otherwise from here only more force will come. Because of that, here it may go for fracture. This is about body of the vertebra. Now we'll see vertebral arch. Vertebral arch. Till now we discussed about body of the vertebra. Over. Now we'll see the arch of the vertebra. Suppose if we see like this, if we see our vertebra, this is anterior portion, and this arch water nerve portion is there. This is posterior portion. Now we are seeing, see here, this is the body of the vertebra. Suppose this is the body of the vertebra. We are seeing superiorly body of the vertebra. The posterior structures are very different, because here we will be having three non-articulating processes and four articulating surfaces. So first if we see, this is body. After that, in this we'll be having, first one is posterior portion. Here will be called pedicles. These are called pedicles of the vertebra. These pedicles are going to again form the transverse process here, and here also transverse process. After this transverse process are coming. This is called lamina. Of the vertebra. This is also lamina of the vertebra. After this lamina, it is going to form the one spinous process. Spinous process of the vertebra. So here between this If you observe one point, this is vertebra, this is anterior portion, this is posterior portion. Okay, this is clear. Now this posterior portion, this transverse process is going to divide the arch of the vertebrae into pedicles and lamina. This transverse process is going to divide the arch of vertebrae into pedicles and lamina. These pedicles are going to connect the entire posterior portion of the vertebra to the body of the vertebra. See here, these pedicles are going to connect entire posterior portion of the vertebra to the body of the vertebra. If you see lamina, superiorly will be having two articular facets in lamina. Superiorly will be having two articular facets in lamina, and inferiorly will be having two articular facets. So these two superior articular facets, also called as zygopophyseal facets. Okay, and inferior articular surfaces. Here also zygopophyseal facets. So these are also called as facet surfaces. So this is the point. See here, three non-articulating process. One transverse process, second transverse process, third spinous process. So these three are the non-articulating processes, and four articulating surface. Two superior articular facets, two inferior articular facets. So these are the four articulating surfaces. So this is the posterior structure of the vertebra. After this lamina, this lamina are going to form this spinous process of the vertebra. So this is about the complete. So this is about the posterior portion of the vertebra. So from here we will be having trabecular system. From here we will be having trabecular systems. Okay, the connection between pedicle and lamina, this is called as the pars interarticularis. What is the importance of this pars interarticularis? We'll see later. So this is the point. Here understand one point: the superior and inferior facets these structures are coming from the lamina. This is nothing but here the space. This is the space for spinal cord. This is the space for spinal cord, simply located spinal foramina. So this is about the posterior structure of the vertebra. Spinal foramina also called as the vertebral foramina for the spinal cord process. So this is about complete post. So this is overall about the structure of the vertebra, both anterior and posterior. Clear?